Now we're going to take a look at several examples of solving rational equations. Our first example is just a linear equation with fractions that we've seen before. But I'm sure we all agree it would be much easier to solve if it didn't contain fractions. So to eliminate the fractions, we want to think to ourselves, what can we multiply both sides of the equation by to eliminate the denominators of 15, 6, and 5? Well, that would have to be the least common multiple or least common denominator of 15, 6, and 5, which would be 30. 30 is the smallest number that's a multiple of all three of these numbers, and also the smallest number that would divide evenly by all three of these. Which means we're going to multiply both sides of the equation, or each term, by 30. So we're going to rewrite this as 2x over 15, leave some space, minus 1/6, leave some space, equals x over 5. And then we're going to multiply each term by 30, or 30 over 1. And this should eliminate all of the fractions. So now we're going to simplify each product before we multiply. Well, there's 1 15 and 15 and 2 15s and 30. There's 1 6 and 6 and 5 6s and 30. And there's 1 5 and 5 and 6 5s and 30. Notice how now all the denominators are 1, so the fractions have been eliminated. So this first product would be 2x times 2, that's 4x, minus, here we just have 1 times 5, that's 5, equals, over here we have x times 6, or 6x. And now we'll solve this equation for x. So let's go ahead and subtract 4x on both sides of the equation. This will give us 0, so we have negative 5 equals, this would be 2x. Divide both sides by 2, so we have negative 5 halves equals x. Or we can write x equals negative 5 halves. Now the rational equations we want to solve are going to have variables in the denominator. And so there's a couple more things we have to be concerned about when solving rational equations with variables in the denominator. The main idea is the same though. We want to figure out what we can multiply both sides of the equation by to eliminate the denominators of x minus 3 and x plus 2. Well, the least common denominator, or the least common multiple of these two expressions, would be the product of the two expressions, which means we're going to multiply both sides of the equation by the quantity x minus 3 and the quantity x plus 2. So again, we'll start with the original equation. We have 5 over x minus 3 equals 4 over x plus 2. And now we're going to multiply both sides of the equation by this product. So we'll have x minus 3 times the quantity x plus 2 all over 1. And we'll do the same on the right side. Notice when we do this, on the left side of the equation, we have an x minus 3 over x minus 3. That simplifies to 1. And on the right side, we have an x plus 2 over an x plus 2. Again, notice how now the denominators are equal to 1. So we're left with the quantity x plus 2 times 5, or 5 times the quantity x plus 2, must equal 4 times the quantity x minus 3. Now we'll clear the parentheses and solve for x. So we'll distribute here and here. So we'll have 5x plus 10 equals 4x minus 12. So now we'll get x on one side of the equation, so we'll go ahead and subtract 4x on both sides. At the same time, let's go ahead and subtract 10. So this will be x, this is 0, equals, this is 0, this is going to be negative 22, which would be our solution. Now there's one more important thing that we need to know about when solving rational equations. We know division by 0 is undefined, so looking at the original equation, we know x can never be equal to positive 3, since that would make this denominator equal to 0, and we know x can also never be equal to negative 2, because it would make this denominator equal to 0. So when solving a rational equation with variables in the denominators, we need to be aware of these excluded values, because sometimes when solving an equation using this method, it is possible to come up with one of these excluded values. And those are called extraneous solutions, And if they do occur, we need to make sure that we do not list them as solutions. Okay, we'll look at several more examples in the next few videos.